Word sense disambiguation by Asma Kauser and Joshimuddin. Word sense disambiguation in computation linguistics is the process of identifying and analyzing the meaning of words in context, as this is an open problem of natural language processing, which governs the process of which sense of a word, i.e., meaning, is used, since one word written or pronounced has several different meanings used in a sentence. Take, for example, the following sentences. The rebel sees the opportunity to rebel. In this context has two meanings, same spelling but pronounced differently. The first used is a noun which indicates the person who resists authority, control or convention, and the latter being a verb, being the action taken by the person. Also, I read a book and the cover is red. This sentence has the same pronunciation but it is spelled differently, having two totally different meanings. To a human it is obvious the first word used is a former sense and the second, red, is being used as the latter sense. However, developing an algorithm to replicate this human ability can be a difficult task, as is further exemplification by implicit equivocation between read, best book I've read, and read, I read the newspaper. When relating to machine translation, it is identified as a distinctive task, and one of the first problems faced by the system was word sense ambiguity. It became apparent that semantic disambiguation at a lexical level.
Early approaches to word sense disambiguation. There were three early attempts to solve word sense disambiguation. First one was preference semantic. In simple words, a representation of entire sentence would be built up from representation of individual words through the process of semantic interpretation. The second was word expert phrasing. This approach is more highly lexicalized. This approach is based on assumption of human knowledge about knowledge of words rather than knowledge about tools. The third one was pluralite words, a system which is less lexicalized. This system contains modules, same in the NLP system. Over here, NLP system is a natural language processor which contain modules like grammar, phrasers, lexicons, and semantic interpreters. But all three of them has major issues like lack of lexical hierarchy, and high degree of lexicalization. There were other approaches to word sense disambiguation. Dictionary-based approach, which was defined by Michael E. Lusk. It was the first machine-readable dictionary method, used Lusk algorithm. It's based on the assumption that words in a given neighborhood will tend to share a common subject. For example, algorithm used for words pine and cone. Pine has two major senses in Oxford Dictionary. First, tree with needle-shaped leaves. Second, waste away through sorrow or illness. Whereas cone has three meanings. Solid body which narrows to a point. Second, sometimes something of this shape, whether solid or hollow. And third, fruits of certain evergreen trees. The other learning approaches were machine learning approaches towards word sense disambiguation. The first machine learning approach was tagging with thesis categories, developed by Masterman in 1960s. It used simple algorithm that based on repetition of categories associated with words in the same sentence. This approach remained unsuccessful but later was improved by using statistical models of categories. By examining the ambiguous word in text and calculating the most likely possible categories. The latter method was successful when tested on 12 polysemy words, as 92 correct disambiguation words were found. The other machine learning approach towards word sense disambiguation was clustering word usage, which used Yorosky algorithm for unsupervised learning to find hidden structures in the unlabeled data. Uses one sense per calculation and one sense per discourse of human language or word sense disambiguation. This actual disambiguation is carried out with users decision list. This decision list is based on one sense per calculation property and start with large set of possible calculation and calculate likelihoods of words per sense probability for each calculation. The higher the long likelihood, the more productive evidence.
Summary. WSD is a long-standing problem in language processing. Early problems suffered from lack of coverage due to lack of lexical resources. The early approaches were not fully successful as they had some issues like lack of lexical hierarchy, a higher degree of lexicalization due to large size of vocabulary. More successful was the machine learning approaches. Thank you for listening.